Hello everyone, good morning. Welcome to AWS User Group Nashik, and we are glad to have you after our June's live stream. In July, we were not able to conduct a session, but here we are for the August meetup. We have a very exciting session planned today, and thank you once again for joining on a Saturday morning. I know it's not easy to catch up on the streams on the weekend, but yeah, we appreciate it. So today we have Yash Garudkar, who is tech lead at Vinz Global. Uh, he's practicing AWS. He's expert in front end technologies, and he's gonna conduct a session today. Without wasting time, I will bring him on stage, and we will discuss further. So, hi Yash. I hope you can hear me, and
Yeah, I can hear you. So yeah, hi,
yes.
hello everyone. Hi, Abhishek. Yeah,
Yeah. So Yash, I think what we can do is like you can introduce yourself first to our audience, and after that we will discuss a bit about agenda, and then we'll take further towards the session. So yeah, over to you.
sure. Yeah. So hello everyone. Today I'm going to do a session on AWS EC2 instances, which is Elastic Cloud Compute, sorry, Compute Cloud, and the RDS, which is a relational database service, and allows you to create database for multiple, a lot of dialects actually, Aurora DB, MySQL, Postgres, a lot of options are available there. So I'm going to show you how we can deploy a Node.js API. So first of all, we are going to take a look at how a Node.js API looks in the code, and I'll show you how you can make that API. After that, we are going to up an instance of EC2, and we are going to SSH into that EC2, or we'll just connect to that EC2 directly from the AWS console, and we'll log in with our GitHub account, which is my GitHub account. It will be yours in your case, and once that is done, you can just run the server on cloud, the Node.js server. You will be able to call the APIs to from that URL that is deployed from the public IPv4 address. And the database we are going to use is going to be hosted on RDS and will be available for our EC2 instance. So we can directly connect from that from the EC2 instance.
Cool. I think that sounds interesting. I will also be looking forward to learning from you today. So I think, yeah, without wasting much time, I think we can get started with the session. I'll be at the backstage and I'll be monitoring the chat also. Before getting started, I would just like to, ask our audience if you have any questions during the session or after the session, you can put them in the chat. We will be monitoring it. If you have any questions, we will make sure to get it answered from Yash, and I hope you also will like the session. So yeah, we'll get started. Yes, over to you. You can share your screen. I will add it to the stage and I'll go backstage. Yeah.
That sounds good. Yeah, cool. I'll share my screen.
Sure.
I have some slides to show so we can have a good idea about what AWS EC2 and RDS are doing and what they do. So yeah, I'll get started and I'll share my screen. Just a minute.
Works.
Abhishek, just give me a confirmation if you can see the screen.
Yes, I think it's up and we can see the presentation as well. So yeah, I think we are good and we can get started. If you can go into the presentation mode so that it is visible properly. Yeah,
Yeah,
that's
I have
perfect.
zoomed in.
Yeah, over to you. Yes, we can get started.
Great.
Yep.
So, so first of all, welcome everyone. I'm going to show you how to deploy a Node.js API on an EC2 instance with Postgres database, which will be hosted on an RDS instance, which is the relational database service, as I mentioned. So, what is an EC2 instance and an RDS instance? So EC2, which stands for Elastic Compute Cloud, allows you to run virtual servers in the cloud. EC2 is flexible, scalable, and cost effective for hosting applications. You can choose the resources you need and you can scale them as your traffic grows. So if you have a lot of people coming on your application, the traffic is increasing, there is going to be a lot of load, you can scale your instance, you can improve the way it handles the load. Amazon RDS Amazon RDS is a managed service that makes it easy to set up and operate and scale the relational database in the cloud. So RDS simplifies the database management with automated backups, patching, scaling, and allows you to focus on your application rather than infrastructure. In a let's say you are not using an RDS database, RDS service or an RDS instance, and you are trying to create your own bare metal server and setting up your cloud by yourself. uh, the performance first of all, the performance will be affected a lot, and the time that will be consumed to do that setup will be a lot. And as you know, time is money. You lose money when you give a lot of time on this kind of stuff, whereas RDS allows you to do everything and everything that you want to do on the same platform that you want to build upon, which is in our case is Postgres, which allows you to do automatic backups, which is very helpful. That what I have seen. Let's see what are the key features of an Amazon EC2 instance. So scalability. Easily you can scale up your instances and you can scale down your instances. So you can, you can have a lot of instances running in parallel. You can have, you can scale those instances parallelly, and this allows you to, manage your load, manage your traffic on your site or on your server in a much better way. Flexibility, which is choosing different instance types, OS operating systems, and the software packages. So everyone has different needs, and according to our needs, we can create our instances, which basically means you can have a different type of RAM associated to your instance. You can have a different type of database, not database, sorry, the disk size of your instance. If I want to, today what we are going to look at is a simple Node.js API, which does not take a lot of space, does not take a lot of RAM to run, but there might be someone in the audience who might need a better way to handle a lot of workload, right? So they have a single application which takes a lot of RAM, a lot of disk space. So they can use they can structure, they can use the instance, EC2 instance. You can structure it like that, and you can give that flexibility to it. Same coming to OS and software packages. It can adhere, it can easily, you can set up all your operating system, all your software packages, which will be very easy for the person who is doing this deployment and setting up the instance for the first time. Cost. Pay only for what you use. So there are on-demand instances, reserved instances, and spot instances. So there are different types of instances that EC2 provides you, which allows you to, which are not heavy on the pocket, right? They are, I'm really sorry. So they are not very highly priced. They, you only pay for what you use, as it is as simple as it says on your screen right now. You only pay for how much you use that instance. The security, secure computing environment with Amazon VPC, security groups, and IAM rules. So Amazon VPC allows you to connect to your EC2 and manage your virtual space in a much secure manner. Security groups is used for inbound and outbound traffic for your server. And IAM roles are the people. IAM role, a single role is, you can say, a login ID and password. It's much more than that, but I'm just boiling it down to as simple as possible. I can make it for you, which helps you understand, which helps you understand, and which helps you connect to your EC2 and your EC2 communicating with other Amazon services that are available in a much easier and much secure way. Now let's take a look at the use cases of an Amazon EC2 instance. It can give you web hosting. You can run web applications on scalable virtual servers, which is what we are going to do today. Big data, analyze big data workloads and high computing power. As I said, you can configure your EC2 instance for high computing power. You can increase your RAM, you can select everything that's possible for your server. Development and testing, creating isolated environments for software development. So you can have multiple instances, right? So in our case, what I've seen is what we do for production level applications. We have different instances for different types or different stages of development in Agile. Uh, Mainly, we start with a development server, which is for developers to use for backend. So you can use one single instance, and everyone is communicating for an API for front end people, right? And then there is a UAT server, which is for testing purposes. It is It is where the feature has been completed and we put our software there. So it can be tested by the QA leads and the QA people, which will help us determine any issues that exist in our system. And finally, there is a production instance. So these are three types of instances that I have told you right now, but a lot of them can be created as per the requirement of our software. High performance computing, execute complex simulations and computations. So this is a very important place, not place, but it's a very important thing to do when you have a big software going on, right? So I have a few friends who work in the medical industry, and they are working in cancer research institute, where there are cancer cells. The image sizes are in TBs. I have seen the image, a single image size maybe like a thousand, like a 1 TB, 2 TB, 3 TB, which is terabytes, right? A single image for that. That is a crazy number. Now, when you are dealing with that size of an image itself, the computation, the complex simulations, and the time that it takes to load is going to be massive. So for that reason, you need a high computing environment that can handle that workload. That can be done in EC2 when you scale up your instance while configuring it, right? Now let's take a look at the key features of Amazon RDS. Amazon RDS is a relational database service. So it takes automated backups, daily snapshots, and transaction logs. Multiple A to Z employment, which is high deployment, sorry, which is high availability and failover support. So it is highly available throughout all the available A to Z, the regions of AWS, that is, and failover support. Whenever there is a whenever there is a database failure, Amazon provides you a lot of support in that aspect, which helps you get back up and running in a very less amount of time. Read replicas improve read performance and scalability. Read performance is basically getting the data, reading the data. It is it is very scalable, and it is very easy and very faster to read. It creates you can create replicas, and it helps you do a faster read operation from the database. Automatic software patching, which is updating the software while it is in a downtime, right? So what happens is, let's say Postgres, the current Postgres version that is up right now, which I am assuming is, I think the last I read is 16. So let's say there is a version that is updated, it is 17 version, right? So Amazon RDS will automatically update your database. It will be a minimal downtime, and your database will be updated very fast, and it will be automatic, so you don't have to worry about updating the software, making sure all the things are working fine. Amazon RDS does it everything for you out of the box. Now let's take a look at use cases of RDS. Web applications, so you can store and manage your user data securely, which is what we are going to do today in Postgres. Data warehousing, analyzing large data sets using Amazon RDS and PostgreSQL, MySQL, then Aurora DB, and a lot of options that are available. I will share it and I'll show you soon. E-commerce applications, managing transactional data reliably. So when we come to an e-commerce application, let's say Amazon, right? You go to Amazon, you're trying to buy something, and there is a transaction that happens, right? The data is being updated in the database, you are making payments. All this is transactional data. These are types of transactions. So it is very important these transactions are managed properly, and this is for that is where that is where the RDS shines a lot. Mobile applications, backend database for mobile apps with low latency access. So you can also use the Amazon RDS for mobile application as a backend for low latency, which means that you can connect and you can work with the database in a very faster way. Now let's take a look at when to use what, when to use an EC2 instance. You need full control over the OS and the software stack. So basically, for our case, I'm going to use a Linux server, but you can have a workload which runs on Windows, which runs on Mac OS. So you can select that OS for your instance, and you can have a full control over that OS and the software stack. So whichever software you want to run over Windows or Mac OS or whatever, so that will be available for you, and you will have full control over the configuration of this of your instance. Then running non-relational databases configuration or custom database configurations. So you can create non-relational database configuration and custom database configurations according to your software needs. And it is best when if you want high flexibility in instance configuration. As I said, it allows you to be very flexible in the way you configure your instances. When to use RDS? When you need a fully relational database service which is fully managed, you should use RDS. You want to focus on app deployment and app development without worrying about the database management. That is where RDS shines. All you have to do is set up the instance once, and then you can just focus on the work, on the features, on the tasks that you're working on in day to day. You don't have to worry about database management anymore. When you require automated backups, which has proved a B2B a boon for a lot of software companies, automated backups, scaling and maintenance, right? So when it comes to software or a website, let's say, it is the end user, all they are going to care about is if it is available where I'm using it right now or not. And a lot of blunders can happen. Someone may do a wrong commit, or maybe the database was deleted by some instance, which has happened in recent times and a lot of companies. These automated backups come very handy. So all the database engineer has to do is go to their RDS instance, look for the last backup that was available, and all they have to do is just restore that last snapshot to the RDS instance. Now, I think that's the end of my presentation. Now we can get started on building the application. Okay. So yeah, I'm going to reshare my screen. Just give me a minute. I'll just open the required tabs on our web. Just a minute. So I'm going to dive right into it. Apart from this, I need to show you the code. So I'm going to start with the code itself. Uh, the code is written already. I didn't want to take a lot of your time today. It is already, if you can see the description of our live YouTube URL from the description of this YouTube video that you're on right now, you can see a GitHub URL linked or pasted over there. And if you go there, this is the branch you will, this is the code that you will look at. This is the Git repository. Okay. So one by one, I'll just walk you through the application. I'll start from our server.tsi. It's a very basic, a very simple server to get started. If you are someone who wants to get started with the Node.js API with a TypeScript setup and everything ready to go, all you have to do is just clone this on your machine, change the remote URL and push it to your own repository, push it to your own GitHub, and get started right away. Make sure you have the required env database variables as well. I will share the env file, the structure for env file in the comments soon. So yeah, this is my .env config that I'm using for getting the env variables. This is our course setup. I need a body parser when I send some data from the JSON body. Then this is Morgan. Morgan is something that I am using for consoling the data. Uh, Uh, Consoling means whenever there is a API call, whenever there is any type of request and actual request only, any type of request that was sent, Morgan takes care of that. It works as a middleware and it logs that request on your terminal. It comes very handy when you are in development mode. Then I have my chalk import, which is it is used for consoling with colors. I like the way it looks. It's just a very simple setup. Then this is our hello world URL, which is like a confirmation. I like to use in my backends a slash root slash basically URL, which shows that the server is up now. I can see the database. So on the slash, just our IP, which is going to be is the hello world message. Then I have my tasks route handler. We are going to build a to do API or task manager, right? Then this is my database driver. I'm using SQLize. to connect to the database and do the database operations. It is very easy to set up. It is very easy to use, and it's smooth as it can be. Okay. First, I connect to my database, and after that, I run my server because my server is useless if it is not connected to the database. So it works in a database. It works in a promise format. This is my promise of database. It connects. If it's successful, I go and my server is started. If it is not successful, it will just throw an error in red color. Now let's go without further ado to our route file. Task.route.ts. I simply import the router in Express and I set up two routes, which is create and get. One is a post for creation and one is get for getting the data from the database. This is our task controller. Controller is basically where I have written functions to interact with the database using the driver, using the database model. There are two functions as you can see that we have used in the router file, exported from it, imported in there. One is creation and another is get. So how do I create a task? How do I create an object in the database in our task table? I'll go to the task table, but I think yeah, it is the right time to go to the task model. So this is our task model. It only has three values right now, three columns right now. One is the ID, which is going to act as a primary key. Its default value is going to be a UUID v4. I like to use UUID. This is a very highly accepted standard. Apart from this, I would suggest you guys to use nanoids also. Nanoid is also a very easy and a very simple setup to do, and they are very reliable. And the size of a nanoid is very small. Apart from that, we have the title of our task and the description of our task. Title is going to be a string and description is going to be string as well. A simple setup. Equalize takes an object which is called DB, which is exported from our driver. I'll go to the driver soon. And model name is task. This is the name that is going to appear in your database. This is the name of your table. Now, what is this database driver? To create this structure, it will need a connection to the database, right? So the connection exists in our database slash driver. This driver.ts file. Sorry. So we have imported Sequelize and we have imported our task model. The task model import is just required whenever the database is connected. It just creates a table. Then I have our sorry, I have our DB variables, which is username, password, database URL, then database name, then the host, which is a URL. Then I have our SSL setup. The port is 5432. Dialect is going to be Postgres. Dialect means which type of database you're trying to connect to. If I was using MySQL, it would say MySQL. These are dialect options. We are going to use an Amazon RDS instance. So RDS, when connecting to a EC2 instance, it is a SSL access. It tries to connect to that database with an SSL connection. And when we are in production, it is going to say it is going to use these options that are required. And yeah, where all these variables are passed to this new Sequelize class, and it returns an object of database which is used throughout the application. Sorry. Back to our controller. Creation of a task. The data value, which is title and description, will be sent from in a JSON format from our Postman. Okay. I will also share the Postman object. What I will try to do, I will create a Postman collection. I will push it into the same repository after our session, so you can easily get started from there as well. So I send a title and description in the body, and I create a check data. I'm checking this data. I'm creating an object basically. When I call this function await task.create, it is going to create an object that Equalize understands and contains values. Right now, this is not saved in our database. To go ahead and create that to create that object in our database, we are going to call .save function. The response dot status rest dot status is basically the response we are sending back to the postman or back to the client, right, wherever the request was made from. So it says here rest.status 200, which is a 200 which is created. Okay. And I send a JSON object which says success true, and data I'm sending as a JSON format in a JSON format. If anything goes wrong in this try block, it is fall into our catch block. And all I'm doing there, I'm sending a 404 error. I say success is false, and the message is sent. Now getting all the database values, it is very simple. All you have to do is call await task dot find all. It will get all the values in that table in a array format, in a JSON array format, sorry. And all I have to do is just send that data to the client in this response. And similarly, likewise, like above, I take this scratch block and it catches this error and it sends back to the client. I think that's all for our code now. It's time to get started. It's time to create our instance. I'm going to go to our Amazon console. When you log into your Amazon account console, this is the page you will look at. Simply come to the search tab, EC2, you have to search, and you can go to this EC2 page. So this is your EC2 dashboard. I have one instance running, which is this is my own personal blog that I'm working on right now. And let's try to launch a new instance. It is going to be a very simple setup. This is the name of our instance. The OS I'm going to select is Ubuntu OS. I don't need a key pair for login. I'm going to show you right away from the AWS console how you can access it. And the network setting, I'm going to keep it allow traffic from everywhere, and I'm going to allow HTTPS traffic from the internet from anywhere. Uh, I know this is not the best way to do things. I'm suggesting everyone do not do this. Right now, I'm doing this because I want to show it. I want to keep it as simple as possible, and I want to do it very fast. Okay. Once I'm done with the live session, of course, this instance is going to be shut down and it will be deleted. So it is totally fine. Now this is the configure storage type. Okay. So I can select what type of storage I want. I'm selecting a one SSD. I'm going to select one SSD over here. It is already pre-selected. Then I'm going to increase or decrease the size. I need a 6 GB sized. 8 GB size. It allows you to go into 1 GB, but I'm going to keep it 8 just the default value, whatever it was. You have to you can select all. You have all these types available for the SSD, and I'm going to keep it as it is. Going to the advanced details. This is the instance recovery shutdown behavior, all the behaviors that you can configure for your instance. Network setting is done, instance type is done. And now over here, I have selected a T2 micro, which is a default, right? And it is a free tier away eligible. It allows me to run this instance in free tier. So I don't have to pay money, or I don't have to expend, have an expense for the server. Since it is a very small, I can do it. But when I am going to create a new API or a bigger API, a bigger production level app, I'm going to need a bigger instance, right? Now let's take a look. You can see the scroll bar over here. The size of the instances that are available is gigantic, and I just can't. It's really hard to fathom that these are so availably, like easily available to create for simulations and running our tasks. So I'm looking at this one right now. If you can see on the screen, XIE32X large, which is which has a 128V CPU, and look at the memory. It is 3904 gigabytes of memory, and accordingly they are priced also. So you pay for what you use. This is what it means. Uh, this is a very expensive, or like not I won't say expensive. It is fairly priced for the flexibility is provided it is providing, and it says over here 1.306 USD per hour for 96 gigs of memory. Now let's take a look at something which is very small. I think T2 Nano, which is zero point 0.5 gigs of memory, and look at the pricing. It's like 0.0062 USD per hour, which is like very very fairly priced. It is very cheap, I would say, and for the flexibility and the security it provides. So leaving this as it is, I'm going to launch our instance. Proceed without a keypad. I don't need a keypad to connect to that instance. I'm going to launch the instance. It is going to take some time to launch. Now let's wait for a minute. Let's see. It's not yet running. It's in pending state. Let's just wait here. While that is happening, I would like to show you I'd like to tell you how we can connect to the EC2 instance from our GitHub. So I'm not going to manually like upload my GitHub repository, right? I'm not going to have any other way than to clone the repository directly from GitHub. And that method of getting the repository on your instance is called SSH. The way you do it is with an SSH access. So we are going to create a keygen which creates a key on your instance. You copy that key and you put it on your GitHub. So while that is happening, let me just show you how it works. You have to come to your profile and you have to go over here in this SSH and GPG keys. So these are my keys that are created. Let's just wait a minute. The key that is generated on your EC2 instance is going to be put in this value or this input field. It begins with an SSH hyphen RSA, which is it says ID underscore RSA dot PUB if I'm not wrong. Just a minute. Let's see if it's yeah. Our server is running now. Now I'm going to connect to our EC2 instance, and there we go. Just a minute. It's hard to type with my watch on. Okay, so we are in our instance now. I'm going to use a command which is ssh hyphen keygen hyphen p rsa and hyphen b 4096 hyphen hyphen capital C and my email ID. So now this email ID is very important to be that you have, which is your which is going to be used on your GitHub account, right? So my my key has been created. It exists in this dot ssh id underscore sha rsa. So I'm going to stop sharing my screen here and just copy that string from the RSA file and I'm going to put it in our sh in our GitHub. Okay, asking me for my authenticator code. Okay, I've added my SSH key now. Let's I'll share back the screen. As you can see over here, this to do AWS demo, this key is now inserted, and yeah, we are back in our instance. So once the key is generated and saved into my GitHub, all I have to do is go to my get this URL, my GitHub repository. I'm going to select SSH for the clone, copy this URL, and I'm going to just clone it over here with simple git clone command. That's it. It is going to ask me to add GitHub to my it adds the to known hosts, the GitHub. As you can see, the repository has been cloned, and I have cloned it in the wrong folder. Okay. Okay. I'm going to have to remove that. I don't like that. Okay. I'm going to create a folder. Now let's clone it again. Hmm, cool, it's cloned. To do CRUD AWS session, now I'm going to cd into our app ls here. I'm in our application now. Now what we need to do is the server is up. The server has operating system installed. It has my repository. Now what the next thing that I'm going to need for the Node.js API is my Node.js my Node.js code, right? So not Node.js code, the Node.js itself. I need Node.js to run my Node.js application. It's as simple as that. For that, we are going to use NVM, which is Node Version Manager, and the best way to do to install a node node on your instance or even on your local machine also. I like to use NVM only because managing a lot of node version is a pain when you it comes to doing it manually. NVM just makes it easier for you. Yeah, that's it. It's installed. I don't want to restart my reconnect to the server. I'm just going to. So what I did was at the once this curl URL has ran, it downloads NVM on this machine, and you have to copy this export line, copy this whole, paste it again in the terminal and give an enter. Or what it does is it loads NVM in your bash rc file, which means I can now type nvm -v, and it will tell me the version that I'm using of NVM, which is 0.40.1. Now NVM is installed. I want to install Node.js finally. I'm going to install for 20.14, which is the latest version of Node.js. Will install. It's lightning fast. Oh, it's installed now. Here. Uh, let's check if the install was successful. Yes, Node-v says 20 not 14 not 0, which is the latest version that I had installed. Now let's install Yarn, which is my go-to package manager. I don't use npm very often. It does not manage the packages in our application as efficiently as Yarn does. Yarn has a caching feature which is very helpful. So everything is done now. Now it's finally time to create our env file. So I'm going to touch.env, which creates the file. ls-a, it shows all the files. I can see env is created. I'm going to edit the env file. Now it is time to get the code inside the env, not code, the env variables will be a much appropriate name. Few of these env variables are might not be in use. I'm not sure because Let me just first walk you through the env variables. I will connect with Abhishek and find a way if I can, or I'll just commit a local env file to the repo itself, so you won't have to worry about this. So node env is development, which is incorrect. We have to move this to production, right? So it should say production, and the SSL is true, and yeah, DB name is to do CRUD, but when we create the RDS instance, the DB name, default DB name is going to be Postgres. So I'm going to make this Postgres. DB password, I'm going to come back and update, and the host name is also something I'm going to come back and update. Or there is a JWT secret which is not required. Alarm or police. If you are a GOT fan, you'll know that. Mm, we don't need that. And at the top of the file, you can see the port, which is 8000. 8000 is the port that on which the server is going to run on, right? So let's just close this file. Now it's time. Now I think our EC2 is very ready to connect, very ready to start our Node.js server, our Node.js API, right? Now let's try to go and create an RDS instance. Mm, I clicked on create database. I'm going to keep everything as simple as possible. I'm going to keep everything at the default state. So I'm trying to make it very simple for you to understand. All I'm going to do is select PostgreSQL. The engine version is whatever is defaultly available. Over here in the templates, I'm going to select free tier because it's a very simple API and not a lot of the work is going to happen there. I'm going to keep the DB instance identifier just as it is. Master username is Postgres. Auto generate the password. I've selected auto generated password, which means when I click on create the instance, it is going to give us the password that I have to store somewhere, right? Now, just a minute. Hmm, Okay, everything is as selected as simple as possible. Yeah, over here in connectivity section, I'm going to select connect to an EC2 compute resource, and I'm going to select our EC2 instance, which is to do underscore app underscore AWS underscore demo. This is selected, and yeah, everything is going to be as simple as possible. Oh, VPC existing. So VPC, I'm going to create a new. Uh, yeah, that's all the setup that needs to be required. Now I'm going to create database. View credentials. I copy my master password. I have to store it somewhere. Let me just open up. Now our database is being created. So let's just wait. It is being created. It's taking a minute. Let's wait. Okay, yeah, I think it's created now. Let's go back to our instance. We are going to need the endpoint over here. This endpoint. Let's open up our env file again. That's my database URL. Now my password. I don't need the quotes around it. So yeah, that's all I need. Production. Yeah, I think we are covered. So this is basic structure of whatever variables that were used in our application, right? So clear that up. So do a yarn install. This will install all the package dependencies in our application. Let's see. There we are. Okay. So just a minute. Yeah. Okay. So our packages dependency are installed now. Let's open the package.json. I just need to see which commands are there, right? So there are three commands, which is build, start, and dev, which are we are going to use dev for starting, like testing the server out. Then start and build are to run the production builds. Now going back, I'm going to do yarn dev. Let's see if it connects to the DB instance. It's a first time connection, so I'm thinking it will take a while. Takes a while. Let me connect to the server again since we created the instances. Since we created the RDS instance and we updated it to connect with the EC2 instance, it is possible it was taking some time due to that. Now all the things must be refreshed and we should be able to connect. Let's see. Yeah, server up, which basically means it has connected to the database, and once it connects to the database, we get a console log which is says servers up. The endpoint it is running on is 8080. So let's try to access. By the way, our instance is up now. So let's try to open a public our public IPv4 address. It is going to blow up, but let's see if we can access it over the 8000 IP port. Sorry. Hmm, Let's confirm our inbound rules allow everywhere. Launch wizard 9. Let's see. I think a permission needs to be added. Security group. There it is. I allowed the traffic from all the IP addresses from in HTTP format. It says not secure because it is on HTTP right now. But when I have a domain, I have my Nginx setup, which allows me to create a whole setup on the backend and have my URL connected to this IP or to this IPv4. You can see at slash just slash the API endpoint on 8000 port, we are getting hello world. Now let's try to call this with some post request, right? Let me open up Postman. Just a minute. Okay, I have created my opened my Postman now. I think my screen is not visible. Abhishek, can you please add my screen? Okay, yeah, it is visible now. Good. I'm going to create. I'm going to create a new collection, and the same collection I'm going to push onto the AWS, not AWS, sorry, my GitHub. But let's just start with a simple HTTP request right now. I'm just simply going to copy this URL, this IP address with my port, and call it in a get request. I get my hello world, right? Now that was our get request for making sure the server is working, right? Now I'm going to paste it over here. Now, if you remember, the URL setup for my tasks was on first the task URL, right? Or just to confirm it was, so we don't go in a debugging loop. I'm going to go to our URL API, go to our here, the server.ts file, and yeah, it says task. So slash task and slash create, and it is going to a post request, of course. And since we are sending the data, and I'm going to send data in raw, select raw over here. I'm going to select JSON. If you remember, we had two key value pairs that need to be sent. One is going to be title. I'm going to say set up a call with Abhishek to discuss my EC2 and RDS session. Now, description is the second key value pair. Uh, Discuss pointers, time, date, plan for AWS to the Nashik coming events. That's my title and description. Let's try to post it now. Yeah, it says success. So if you remember, we had three fields in our database, right? One was ID, second was title, third was description. Now, why is there a fourth and fifth value, which is updated at and created at? These are default values for a single row in your database. Equalize does it itself. You don't have to manage it yourself. That is very convenient and very faster for you to work with. Let me increase the size of font. I think it is little, the visibility is little less. I hope it is visible now. If you cannot see the font, please drop a comment. Cool. So if you can see, we have our title, we have our description. The ID is a UUID v4, and these are updated and created at values. So it is going to be the same because I created it just right now. And yeah, it's good to go. So let's try to. Hmm. Now that our values are created, right? So let me add some more tasks so it looks like a whole application. I'll try to get a single value in the array. It won't be really nice to look at. Uh, just some personal stuff. I will plan. Let's say I'm planning a weekend with friends. Get some pizza, watch movie, etc. And there it is. Another task created. Now these tasks are created, right? We created two tasks. So let's try to get our tasks now. Get is not the best way to name your URL. This is just a simple setup. But when you go into production and when you are creating a whole real, much real application, you should use something that is more relevant to your to your code. In my case, it should have been uh, task slash tasks, which is plural, which means I'm going to get all my tasks in this URL. That's how I would do it to keep it simple, right? Always follow the KISS principle. Just keep it simple, stupid. Now, yeah, it's a get request. It looks correct. Yeah, I called the API. I got an array in response. The first task by default, the first task is the one that I created first. Set up a call with Abhishek to discuss my RDS and EC2 session. Second task is planning the next weekend with my friends. So yeah, that's pretty much it, everyone. Uh, this application is now complete. It is deployed on instance. It is EC2 instance. It uses a database from RDS. It does not have all the correct security parameters, but I know it is it is due to the limited time that we have today. But you can set up your security credentials. I'll connect with Abhishek and we can update the links for the security documentation. You should not have all the traffic from the internet allowed to your instance. That is not the best thing to do when it comes to security, right? Only your machine and the IPs that are trying to access your server from the internet should be allowed to connect with the database and communicate with the database and with your instance. So that's there, and you should configure your security groups in similar manner. Okay. So yeah, now that we were doing all this in dev mode, let's just make sure I don't have to run. It should not be on foreground, right? This process was on foreground. Hello. Yeah. Yeah, okay. So this process was on foreground. What we need to do, we need to put this process in the background. So let's say I do yarn dev and I close this tab. That basically means that session is ended and the terminal was closed. So my API is no longer available and accessible, right? So the server is up and it is running. So if I refresh this page, it is going to say hello, hello world. But now what if I close this server and do a refresh? It will not work. The site cannot be reached because the server is down now. So what we are going to do is npm i-g pm2. PM2 is a tool which demonizes your process, your server, and makes it run in the background. So simply it is installing. Just give it a minute. Okay, yeah, it is installed. Now that PM2 is installed and our application is also ready, we are going to create a build of our Node.js server. Now, why a build? We are using TypeScript. TypeScript is not understood by Node.js. Node.js is a JavaScript engine, not a JavaScript runtime, right? It gives runtime to JavaScript applications. We need to convert our TypeScript code into a JavaScript transpiled code. So I've created the build now. The build directly gets created into a dist folder with the setup that I have right now on the GitHub. You can take a clone and take a look at it for yourself. I'm just going to do ls. You can see a dist folder was created, right? This folder is always created and always updated even when you are in dev mode. If you make some file change and save that file, the server will spin up automatically, create the dist folder automatically, and it is very fast. So it is always inside the dist folder. But when I run yarn build, this build inside the dist folder relates to the build command. It takes those variables. Our dist folder is ready. Now let's clear the console. The file that exists in the dist folder is slash server.js. So pm2 start. This is the pm2 command to starting a JavaScript application. Then I give it the path, which is dist slash server.js. And there it is. This is the PM2 monogram, the logo that they have in the terminal. You can see this server name for PID status online, which means our server is running now. I clear this out. PM2 status. Sorry, type PM2 start, PM2 status, and you can see the application is online now. The server is not running. You can see I have exited all the processes. I have exited. I have logged out of the server even, right? So I cannot access this server and typing, nothing works. But now if I go to my IP and I hit refresh, I can see my server. So I can simply just close this tab and refresh it as I want, add my task, get my task, everything runs fine. So yeah, that's it for today from my end. Thanks for joining in, everyone who joined in. Thanks for your time. I really appreciate AWS UG India and AWS UG Nashik, and thank you Abhishek for having me here. So yeah, are you there, Abhishek? Yeah,
Hey, yeah, Yash. I think that was a really great session. I enjoyed every bit of it. I like the demo part of it where you have, went into each and every detail. So yeah, I hope the viewers also would have enjoyed it. Also, I don't see any comments as of now, but I think we will
okay,
monitor the chat on the YouTube, and
sure,
if our audience is watching this live stream in later point in time, they can still put their comments, and we will make sure to monitor and get them all the questions answered.
definitely.
So yeah, I think thank you so much, Yash, for taking out time today to conduct a session here. And I think we will definitely get in touch with you to host such a practical sessions in future as well. Just before
Definitely.
closing out, I would just like to highlight a few things to our audience. If you have not joined the AWS User Group Nashik, and if you are not a member of AWS User Group Nashik Meetup group, you can as you can see on my screen, you can go to Meetup. I will put the link in the chat box and the description. You can go there and join the group. You will get all the future events information from here. And as you can see, we have 534 members as of now, and we are targeting the 1,000 members by this year end. and I'm sure we will be definitely reaching that point. So yeah, I'll put the link, and you can definitely be a member of AWS User Group Nashik. If you are not on Meetup, you can definitely go to the LinkedIn, and you can find the AWS User Group Nashik page, and there also you will get the updates and notification regarding the future sessions. And before closing, I would just want to announce that on 14th of September we are planning a physical session of AWS User Group Nashik in Nashik. The location and the session details and speakers, would be announced on the Meetup group and a LinkedIn channel in the coming week, which is upcoming week. And we hope to see you all there. Whoever can join from Nashik, whoever lives in Nashik, will be definitely happy to host you there. And I think let's make that event a great success. And stay tuned for more. Follow the channels, and you will be able to get the all the information. So yeah, with that note, thank you so much for our audience today to joining in on a Saturday morning. Thank you to Yash again, and see you again.
Welcome. Happy to be. Thank you. Thank you. Thank you, Abhishek. Thank you, everyone.
Thank you,
Bye.
everyone.